Hi everybody and welcome to this session about .NET deobfuscation of Eternity Malware. Eternity is actually some kind of project and this project is available on some Onion website, but they actually produce, they are making available some more malware samples, like more malware oriented things, worms, coin miners, stealers and other things. And today we will basically write a deobfuscator for Steeler. But the funny thing is actually that they are producing these things with some kind of builder, and this builder is using custom obfuscator, probably the same on all samples. So once we will create this the obfuscator, it should work on all kind of sample of Eternity project. Again, some kind of custom obfuscation. So in this video, we will be using PowerShell and dnlib. And we'll be writing actually some kind of string decryptor, the obfuscator for this kind of sample. And this video is not just only about Eternity. Eternity was just grabbed as an example, but I will show you how you can actually do these things universally for more kind of samples. Why PowerShell is quite a cool to use for deobfuscating things very fast. Mostly you will see that reverse engineers, like the more advanced, that actually write some deobfuscator by their own, are all usually using C#. C# is great, and in many situations it's better than PowerShell, but in many situations also PowerShell shines, and it's much better than C#, faster. It's like comparing Python to C. Some things and some routines you will do in Python much faster, and that's it. Basically, PowerShell is scripting language, so why not? Why not? Because PowerShell is actually built on top of the .NET. So yeah, but how we can do it? How we can do it and why it's so super cool? I will show you all right now, and I hope you will enjoy that. So let's start. First of all, here is the original Eternity Stealer. I would like to mention that I already created the deobfuscator. Yeah, we will not be doing it here from the scratch. We will be doing it from the scratch, but I will not be writing it again. So I will just comment and explain to you everything I did, so you can reproduce it on this sample or on other kind of different samples. This is just some kind of guide how you can write a deobfuscator and why it is so cool and so tricky to do it in PowerShell. So this is the original sample, and there are some like already deobfuscated things. I would like to firstly probably start with showing the sample in DnSpy. So once you check the sample, you can see right immediately that there is something strange. First of all, some kind of silly computation, but I think that this computation could be deleted or removed, or you can get rid of it by default dot. Maybe the size of some things could be more trouble, like could be quite more like strange, but you can, I will show you how we can get rid of this too, but that's not the subject of this deobfuscation, like of this video. We need to get mainly the strings and other things, because we can't see it here. You can see here something like this sometimes, and yeah, different. So what actually happens here? This is some kind of method actually using, yeah, you can see that here is some kind of string which will serve for mutex creation. But what actually this function takes? Some string, and the string is produced by this function. This function takes like some, oh, this one, one string and integer 64. Yeah, and producing string. Yeah, and you can see that this function actually takes string and long, yeah, integer 64, and this is here. So basically, the funny or tricky thing about this obfuscation is that they actually join like two methods. like decryption method 1 to decryption method main, and this will just produce the decrypted string. You can see this method. First of all, this method just takes some string, and produces string. There is some XOR decryption. Nice. So you can see that this method is actually taking some other result of methods. Yeah, that's pretty silly. But if you check these methods, there are some kind of dummy methods, basically just loading string and returning. Yeah, because if you check the IL code of this, you can see it's just load string and return. Some kind of dummy methods, and this is the same. Well, so we need to somehow grab these strings, the results of this, and push it to this function. This function will perform some decryption, XOR decryption, and okay, we will just do it dynamically. We will be invoking it via reflection. I will not be like implementing this function and implementing this function, the second routine. We can do it, but I think that these routines practically these routines could be far more sophisticated, like really far more sophisticated, and you don't want to replicate it. You don't want to like sometimes it could be just copy paste like from the C# decompiler to your Visual Studio project, but sometimes not. Yeah, and the dynamically way of like invocation is more cool and more tricky. So we need to just firstly grab these things, yeah, produce invoke this function, grab the result string and put it as argument to the main decryption routine with the integer value. And this routine is just again doing some decoding. I don't care what it's doing. Yeah, it's just taking a string and taking long. Yeah, and it's returning string. So what we would like to actually do, we need to find some the thing, like the main method, decryption method, which is like the really main, and we would like to find it like all location from where it's referenced, the call to this method, and this. It's actually this method. Yeah, so we need to find all location in this assembly where this method is used. After we find that, we need to just take like these things. Yeah, so if you check that, we will be working on the IL level. Yeah, so you can switch from the C# view to IL view, and you can see this is the IL level. Yeah, so we will be actually processing the instructions like opcodes and operands. And if you just check it here, I quite find useful this window edit IL instruction because it will highlight the instructions. You can see here, this is our method actually. You can see it here, the ISQ, yeah. And this, yeah. So we actually need to find all references, core references to this method. Once we find them, we need to just take the argument, like the integer 64, save it, and we need to just take result of this method, push it as arguments to this decryption routine 2, return the result string, save it as a second argument, first argument, second argument, and push it to the main decryption routine. Yeah, so actually the result of this the second decryption routine is the first argument, and the integer 64 is second argument. Once we will be done with this, we will get the decrypted string produced by this method. And we need to actually replace this instruction. We will probably replace the first one instruction and remove or nop of this rest of instructions. Yeah, so the best would be probably patch the first one and for something like load string, the decrypted string, and the rest of it we can just remove. And that's cool. That's really cool. But there is a problem, because you can see here that the second decryption routine is taking here in this case In this case, you can see that it's taking results of these dummy methods. So there are some like call instructions. Yeah, we saw that. Call, call. Yeah, but that's not true in all cases. For example, if you check this, you can see here the same routine, but now the IQG, the second decryption routine, IQG, is now taking the string directly, so no dummy methods calls. Yeah, so that's pretty strange. You can see it here, edit IL instruction, and you can see here that we don't have the call and some dummy method, the call dummy method. Now we have just the real load string, yeah, just only these instructions. So we need to count with this when we will be writing the deobfuscator. Yeah, that there are more cases to cover. I will refresh it once we will be in that point in writing the deobfuscator. So yeah, so first of all, I will just do a little recap. So we will start with just spawning the PowerShell like in Visual Studio Code, and we will load the dnlib via reflection, and after we load the dnlib via reflection, we can use it. After that, we will load the malware, the assembly I showed you, yeah, now. So we will load it as a module definition, which is some kind of type of dnlib, and we will also load it via reflection. So it will be like the module itself, the malware will be loaded 2 times. First time via the dnlib as a module definition, and second time as a assembly object via reflection. Why? Because dnlib and assumer resolver and other open source libraries, parsing, processing, these kind of things, to actually modified IL code or .NET metadata, these things works more securely. Yeah, so they are actually parsing the .NET assembly, .NET module in a secure way, and they are not using or relying on reflection. So that's pretty cool, but there is quite a some kind of point, because it's secure. You can actually invoke function, yeah, from this parsed binary via dnlib or assumer resolver. It's just some kind of structures of data. Yeah, you can invoke function via reflection. Yeah, so this is the reason why we are loading it also via reflection, because we will be using the dnlib to parse everything, to get the results very fastly and secure way, and we will there are some like cool things, much better. Basically, reflection, we can grab or take or get almost like most of the information we can get from the dnlib also via reflection. Yeah, but dnlib has some kind of shortcuts and cool things to do it fastly and other things, so that's better to use just the dnlib for the parsing, and for the invocation, the reflection. After we will have prepared this part, this will be very quick. We need to find the string decryption method. The first one, the main. I actually already pointed you that this is the one. Once we find like all location, like no, we need to identify this method actually. Yeah, so it's here. Yeah, but we need to identify this routine somehow, universal way. Yeah, because the naming is obfuscated, like name obfuscation. So every sample will use different names for methods, classes, and other things. So we need to find some kind of like signature or something like that, and write it to actually find every time in every sample this kind of method. Once we find it, we also create some kind of global variable to collect all methods we will be removing after processing. Yeah, so once we just find, for example, the dummy methods, we will process it, and after we don't need it anymore, because we will replace all location where it is used. So we will also remove the unused types like methods and other things. So we will create some kind of global variables, and we will be adding the methods to it, which will be later like removed. After that, we have to find like all call references to our string decryption method. Yeah, so you can see that, for example, from here it's like a reference, it's called, and here is also it's called. So yeah, we need to find all of these locations. After that, we need to like process this location to find arguments to decrypt like string using invoking string. Yeah, so we actually like need to grab the arguments to the main decryption function. As I already like told you or showed you that we need to somehow grab it, process it, get the results, and invoke the decryption routine on a reflectively loaded malware. So we will be processing the instructions. And once we get the decrypted string, we need to patch the location with the decrypted string. Yeah, so we need to patch the code with the decrypted result and remove the instructions which are not which were related to string decryption, but we don't need it anymore. Yeah, so we will be just also patching the instructions. Yeah, and after this is just main routine to decrypt all strings, but we need to also get rid of the dummy methods, which are actually served like some kind of proxy calls, which just return only the strings. Yeah, so that there is no encrypted string, but yeah, it's much better to see the string directly than some kind of call to function which return strings. And yep, find all those methods and location from where they are called, and replace all the location with the string value function, something like function inlining, yeah, with the resulted string. And finally, we will remove all methods that are not needed anymore. Basically, the from the global variable we filled here. Nice. So let's start. Here you can of course see the um, produced string, and I will explain all things here. It's not so long, it's like 100 lines, but it's because like I commented some things which are, I hope, pretty cool and very like useful, because there are things you can hit, like you can hit the wall with these things if you will try it by your own, and there is no like, you don't need to repeat some kind of mistakes or some kind of things they which doesn't work. I will show you, I will explain. So first of all, as I already mentioned, we need to start with the loading of the dnlib via reflection. Yeah, there is quite a difference. Yeah, because now with this line we will load it to our process, and we have like no real like variable holding the assembly object. Uh, this is actually very useful because you can with this we can try it. I will show you here in PowerShell. So once you do it, now you have some kind of namespace dnlib, and you can actually use it. Yeah, so for example .NET, and I think like module definition md, and for example load. Yeah, so you can actually use that like built-in assembly or like a normal function of .NET. So yeah, if you don't know like what some kind of method like what arguments it takes, just for example, if I do something like this, just do this one and enter, and you will see like the overload definitions. Yeah, so you can see what arguments or what parameters it takes and what type. Yeah, that's pretty interesting and very useful. Now jump back here and let's start. So you can see that first of all we will be loading the dnlib. After that we will just also prepare some path, yeah, paths the sample, our malware sample dot to patch, yeah, and patch dot. Yeah, basically this will be just the location of the patched .NET assembly, our malware sample. And here is some variable which will be holding our effectively loaded malware. And here is the module definition via dnlib of the malware. So let's start. And I will show you what is the pretty cool using like the PowerShell here. So now the dnlib should be loaded, and this actually works like some kind of intermediate window. So once you are in functions and the functions are like local variables, there will be gone once you leave the function. Yeah, but these things are like global variables. They are not real global variables. Yeah, I will explain the differences between global variables and this kind of definition right in the moment. But here you can see that we loaded the dnlib. So now it should be possible to do like dnlib. Yep. Yeah, .NET. Yeah, and you can see that everything is working, because we are just this. Imagine this, that this is some kind of session, yeah, and you have the session. So for example, this, if I just for example do like 10, and you can see that this variable is already assigned. Yeah, once I stop the debugging and I will try to do like this, you will get the result, even though we are not debugging. Yeah, so it's not like only intermediate window. Yeah? So it's like the window for current session. Yeah, but you can window for current session and also the intermediate window. Great. So once again, and yeah, here we prepared the some location, and here is the module definition via reflection. If you want to investigate it, you can actually step over, and here. Sorry, you can, and it should complete also the module reflection, and you can see it's here. Yep, and why it is quite cool, again, the PowerShell itself, because what you can do, you can actually do something like this, git member, and you will find out the type of this like object. It's a runtime module, and you can see that it's a part of reflection. And you can see here all methods or properties it has. Yeah, this object. So you can actually do something like get member, member type, and methods. Yeah, and you will have only the methods. Pretty cool. And you can see, for example, right immediately that yeah, I will explain it later. Now you can also do the same thing for the module definition. Yeah, module definition, and give me, and you can see here some kind of like about the object itself, object instance, but you can also like do this get member. And you now will see that it's not some kind of runtime module definition, but it's like via reflection, but it's a module definition via the nlib. Nice. And this is actually the way, because I don't know. Yeah, man, people just think that I'm some kind of guru .NET master. I know the syntax of dnlib by my own. I don't remember. I don't know. But dnlib has no documentation, and this is very cool that you can investigate all kind of things, like for example module, and if there is something like get types, yeah, so get. Yeah, and you can try, yeah, get types, or you can search here, yeah, get types, and you don't know if it does it take some kind of arguments. You don't know. You can check and you can check the get types that doesn't need any kind of arguments, yeah, but there are some probably other things. Yeah, it's actually like, for example, get, if you would like, for example, get type concrete type specific, you will see that it okay, get type doesn't need an argument. So module definition, maybe method, some kind of method which takes some arguments. Yeah, so maybe resolve, some kind of resolve, maybe method member resolve method. And you can see that you need some kind of argument, yeah. So but you can investigate all by your own, yeah. You don't need any kind of documentation. It's very useful, yeah. So now we are in the moment that we have the module definition and the same module definition but via reflection. Now we are in the part we actually need to find the main decryption function, yeah, this one. Yeah, so we need to somehow locate this one function. Yeah, because you can see if you check the IL code, you can see that it's actually here, the instruction index 5. So what we know about this function, we know that this function actually takes two arguments, string and integer 64, and it's returning string. Yeah, and it has some kind of body. So yeah, this could quite serve as a good start to just give me all methods. First of all, we will just grab all methods of this assembly, and we will try to find a method which has exactly two arguments. The first one should be string, the second one must be integer 64, and the return type value must be string. Yeah, and this should be like unique enough to actually give us the one original, the one unique method, which is this one. So you can see here what this is exactly what we are doing here. Yeah, we can see that we are actually like doing like module definition, get me types, and for each give me all methods. So we will get all methods. Okay, for example, what is pretty cool, you can actually do the same. You can try to do the same here in the window, in the like intermediate window. Get types, and blah 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 blah. You can see it's working. You can, you wanna all types. Yeah, and for example, I wanna just all full names of the types. I don't know if there is like type. What is the property? How I do know that it's a full name property? Yeah, so it's like you can do this like types, and you can do like types, for example, member 0, and oh sorry, maybe there will be file name. Types, maybe to array. Okay, but it's actually not so important. I wanted to show you just a few things, but I will show you on the methods itself. But what you can actually do also is that you can just get all types, and you can write something like this, yeah, get types and methods, and you have all methods. Yeah, so basically the same thing. If you, for example, want to check the count, count, yeah, more than 2000, but you can also, it's the same as this one. Yeah, so that's pretty cool. Yeah, you can do like many cool things, but again, we can step over this, and we have these methods populated, so you can use it now here. Methods, and now I think that you can actually get only the one method. Yeah, methods, and for example count, and you can see we have more than 2000 methods, and that's cool. But I wanted to show you that you can actually get the first one, for example, and you can investigate like what you can find out about this kind of object, what you can use, what properties you can use, what methods, yeah. So You can also use it like this, but be careful, there are differences. Yeah, if you do this get member like this, methods, pipe, and get member, what do you get? You actually get the first member type. Yeah, so first member type is actually module definition, and but it's like one object in the array, yeah, or in the list. So it's a type module definition, and you have some kind of method and some kind of properties. But be careful, because if you want just know the methods like itself, like the array or the list, you need to do like get member and this one input object and like this. Now you can see that it's a collection. Yeah, so now it's like not the result of the processing like the pipe, but actually here. And you can see what you can do on the collection. You can see that you can edit values, remove, add, and other things. So be careful about that, because if you want to just get the type of the one member, you can push it like via through the pipe. But if you wanna like know that there is some, for example, method like clear or something like that on the list or collection, you need to put it in this way, or structure it in this way. Great, so we have all methods. Now there is need to actually perform the find string decryption method, which is actually something I already created. It's here. And it's exactly the same logic I already mentioned. We need to process all methods, like the 2000s and more, and we need to find this exact method. But we can't use things like metadata token or method name or something like that, which is very often changing. We need to use some kind of property, or like how this function looks like from the signature point of view. So what we can actually do, we can again, yeah, we need to find the function which takes first argument string, second argument integer 64, and a returning type is a string. Check it out, and that's exactly what we are doing. So what we can actually do, we can put a breakpoint here. We can put a breakpoint here. Go. You can see that this function I created, it just takes the methods. Yeah, that's all. So you can see that argument is the collection of the methods. And come on, we are here. And the logic, yeah. So we will for each method in methods. So this method, if method has body. Okay, what is this? Yeah. What is this like if method has body? How do I know that the method, again, you are here, so you can do something like that. Method, or you can do methods and you can investigate like the member 0 and get member, and you will see that this has some kind of probably property maybe has method, has body. I can't see it here. Has body property. Yeah, it's returning bool if it has some kind of instruction body. Yeah, because there in .NET there could be like really like empty methods with no instructions at all. This is sometimes useful to you in other obfuscator, like there are empty dummy methods. It looks like dummy. There are, for example, proper way of signature of the method, and the obfuscator is using like some kind of unpacking, and during the runtime it will populate these methods with the ILSbody, but there could be actually empty from the start. And yeah, so we will check if there is some if the method has some kind of body, because we actually are trying to find this method and it has body. So if there is no body, continue, look for other one. Yeah, so if there is, yeah, if there is some kind of body, do this. So, and you can see what we can actually do. We will take the method parameters, yeah, because again, yeah, we can just do this method, and how I know that there is some kind of parameters, yeah, you can try Yeah, you can try because you are in the context, and that is pretty cool. Again, yeah, as I already show you, there are methods as we saw here, and check the methods, and there is a method like okay, I think that parameters is maybe a property. Yeah, parameters is property. Yeah, so you can see how I found that the method definition has some kind of property called parameters, and you can actually try it, what it like return, yeah, what it return, how the return result looks like. You can see parameters, and you can see that it has only one parameter. Yeah, that there is also some kind of, you can use count, and only one parameter, one argument. So this method is taking one argument, but we are looking for the function which is taking two arguments. So this is not interesting for us. What is next? The first parameter. Yeah, because you can see here that if you, for example, do the first parameter, which is actually here the only one, but first parameter, you will get the first parameter like type and other things about that. You can actually go press like type and full name. If you don't know that it has full name, you can check type, and you can see here that there is some property again about full name. Yeah, so like this, and full name, and here it is, system.string, and we need this, and we want to basically the same also for the second parameter, but it needs to be like integer 64. And other cool thing is that we can actually go to like the method and return type. You will get some kind of, again, yeah, the type of the return. But if you want a full name, just do this full name, and you have that something that this exactly method is just returning void, so nothing. Yeah, pretty cool. So we can actually create our signature like to detect our method. We need to find like if there are like two arguments, exactly two arguments, and if the first argument is string, and if the second argument is integer 64, and if the returning type is string. If we will structure like this, we can confirm that we will get only one, and only method. Yeah, so no false positives. So we can actually take this thing or remove this, and we can confirm it. Why? Because you will see I will put a breakpoint here and put a breakpoint here. How many times we will hit the method? Yeah, first time, and you can actually see that it's our method. You can check the MD token 0600003, and if you check here, the metadata token is the same. So we have now our method we want. But is there think we will hit it again? If yes, we need to actually improve our detection. We need to add some things to the condition. Yeah, but no. Yeah, so the only one is written like with these conditions. Great. This is super great because now we have our decryption routine, the main decryption routine located, and we will return the method. And we did it actually in some kind of universal way, so it's pretty cool. So this was covering of the locating of the decryption method, the main decryption method. So we are now here. Yeah, we will return from this, and we can continue. Like here. So now we have populated the decryption method. Yeah, again, yeah, you have here the same, or you can see what you are in the context. So you can actually do like decryption method, and you have it here. Yeah, if you don't know, you can, for example, do MD token, and you can see many cool things. Great, so we have our decryption method. Now we need to actually create the global variable. Here it is, little bit different. Yeah, difference between this. You can see here, for example, that yeah, the difference between this and defining like a variable like this, and because you can see that this is not a part of function. Yeah, it's out of the function. This is some kind of global variables, but they are not real global variables. So, for example, if you would use this variable in a function like this, you can actually access the variable. You can actually grab the currently assigned values, yeah, in function, yeah, of this variable, because it is some kind of global. But what is different, yeah, that any kind of modification to this variable in the function will be preserved only in the context of the function. Once you like once you jump back from the function, return to the normal execution, the modification will not be preserved. So it's not the real global variable. Yeah, so you can actually access this some kind of semi-global or like almost global variable. You can access them, you can get the currently assigned values, and you can work with them in the function, but you can't modify them in the function. Yeah, you can't. Yeah, it will not be preserved. So you need to do this kind of naming. Yeah, so you need to do like global methods to remove. Once you do this, it's a real global variable, and you can push it to function like this, for example, function, and you can modify it. And once you modify it here and return from the function, it will also preserve the modification out of the function. So this is the real global variable. Again, if you would like to really use the global variable, just do this syntax. This is the real global variable. This is some kind of semi-global variable, like you can access it in the function, but you can modify it. Okay, and we created actually this global variable which will be populating, like it will be array of all methods we would like to remove after we process all of instruction, after we do everything. Okay, so we can continue. You can see that first of all I populated with our decryption method, because once we finished this decryption method here, this one actually, yep, so this one will not be needed. Yeah, so because we will be patching the instructions like here, so for example, this will be removed, this will be removed, this, and only here will be decrypt string. But we also want to like remove the definition, yeah, like these definitions of the functions, because it's just like grabbing a space. So yeah, so just no way, we need to, we can remove it. Why not? We can clean it. So this is the reason why I'm populating, oh sorry, why I'm actually populating the list of the functions or methods which will be removed. And here is just silly check, yeah, because if we have no function, if you check this function, if the function if the method decryption will not be found, it will return null. So if it is null, it will tell you that something is wrong. And now the loop, yeah, we will be now processing all methods. And again, the check we already see, if the method has no body, continue. If it has body, if there are instructions, go on. Yeah, do the processing. For example, you can see here that this method should have some kind of body. Let's check it. We can do it. First of all, some information about the method itself. Yeah, nice, some kind of method. Okay. And method, you can see like has body. Should be true. Yeah, it's true. And is it really true? Because we can do something like method. Give me some kind of method body. Okay, method body. There is some kind of method body, and you can see that method body is has some kind of probably property of instructions. So let's get me some instructions. And yeah, we can see here opcodes and operands and some kind of other things. For example, instructions is again, some kind of collection or list. You can make it an array or something like that. And actually, it contains many object type of instruction, because if you, for example, grab the first one, you can see this is some kind of type of instruction. Yeah, for example, if you do like this, again, get member, you will find out what you can actually do on the instruction, on one instruction. Yeah, these are methods and property of one instruction, of the type of the instruction. So you can actually like check many things. Yeah, you can get the opcode or operand and other things. But if you want to check what you can do on the instructions, or on the on the collection, yeah, you need to, I already mentioned, you need to do like get member, and input object will be this one. And you can see that now it's some kind of collection or list. And there are methods, different methods. You can like remove something and add something and blah blah blah, other things not very important. But what you can see here, what I'm doing, why I'm doing array here. Yeah, array. Yeah, one would actually could there will be probably some kind of guru.net masters which will be so checking my video, and they will be like telling, what the fuck, man, hey, why are you creating array? Yeah, because why, if you just do this instructions to array, what you actually are doing, you are doing copy of the instructions, copy of the list. Yeah, why? Yeah, like duplicate. Hey, you are not saving some kind of space. Not, that's not true. I am actually doing it because of some reason. uh if I if I want to do it, what I will be doing actually, I will be processing every instruction of the instruction set of the list, and I will be removing some of them. So I will be actually modifying something what is subject of the for each loop, and this is not possible. You can actually like, because you will be modifying the list which is iterating, and you can't do that. Yeah, so what I am actually doing with this, that I will actually create a copy of the instructions, like with the to array. And what I will be doing, I will be actually iterating the original, in like the copy of the instructions. So we'll be iterating like the array. Yeah, and once we need to do some kind of modification, we will be doing it on the instructions, like on the list. Yeah, so we will not affect the looping subject, the array itself. Yeah, for example, if there are like 25 instructions, and it will be looped all 25 instructions. So for example, if I remove the instruction number 17 and instruction number 20, they will be removed from the instructions what we want, but they will be not removed from the array. Yeah, so we are looping here. So that's pretty important. Remember this, because if you would not do it like this, it is possible to do it without this, without copying the instruction set of the list to array and other things, but you would need to actually like a looping in reverse order. And that's because if you remove, for example, the instruction number 3, it will just can corrupt the instruction set, so you can just like, you can you process the instruction number 4 because you remove the 3 and other things. So you would need to like loop in reverse order, and this is the reason why I just do this like to array, and I don't care. Yeah, I don't care, because it's doing what I want. Great. So this was some kind of more like internal explanation. And here we have the first instruction of this method. Nice. And what I'm doing here, I'm actually trying to find a calls, yeah, the references to our decryption function. For example, if you check here the IL code, you will see here that yeah, I'm trying to find this one. So basically, I am processing all methods, all method body instructions, and once I find a call to the decryption method, to the main one, fuck this shit. View full screen. Okay. once I find the call to the decryption method, to the main one, as I show you here, I need to process it. Yeah, I need to actually like really process it. If it is not the call to this, if the method has no call to the decryption method, to the main decryption string method, I will just ignore it. So we can actually continue once we hit the instruction of call to the decryption method. Continue, and we are here. If we want to check it, we can do again instruction, because we are in the context, and we have the instruction, and you can see that it's a call, and check it out. ISQCTU. ISQCTU. Yeah, that's pretty good. But where we are, because I would like to actually check it in the DnSpy, yeah, because I'm creating something, so I want to know where am I, yeah. So you can actually do what method is now processed, method, and you will see here that here we have the method metadata token of 060002. Copy that, and I think it's that, yeah. And here right click and go to MD token and OX and this one. Yep, and we are here. Sorry for the IL code. And we are here. So we are in this function, and it found this one. It found the decryption routine. Yeah, this one and this one. One of that. Okay. So what I need to know is actually what is for example, if I check it here, edit IL instruction, I can see here the call of for the method somewhere here. You can see here are basically load string 1, load string 2, calling to some decryption function 2, return string is pushed as an argument 1, yeah, here is argument 2, and main decryption routine. It's quite more sophisticated, but it's quite good and cool. So here is basically the instruction like index 13. And I need to find out this index because I want to process these indexes too. Yeah, these instructions. Cool. So how we can do it? We can actually do some kind of method body instruction index of. Yeah, again, method body instructions. And this is actually the reason why I showed you this. If you do this, remember, you will find only the possible attributes like parameters and methods on one instruction, and there is nothing like index of, because it's not the list, it's not the array, yeah. So you need to actually do this input object here, and you will see here that there is some kind of get index of somewhere, or index of index of here. Great. What it takes, like what is the argument to index of? Again, you can do the same method body instructions, and let's say index of, and press enter, and you will see these are the possible overload definition for this functional method index of, which will be performed on the collection. Great, you can see that it takes actually the instruction. Yeah, so give me the instruction which is probably part of the collection, and I will return the index. Nice, that's actually good because we have the instruction and we will return the instruction index. Press F10 and you can see that it's a 13. Yeah, so for example, again, you are still in the context, so you can verify things like index instruction and you can see 13. And if you check it here, it's really 13. Cool. We can actually continue. Wow, this sucks. Continue, and what we are taking now, we have now the index. Yeah, so it's like the position in the array. Yeah, so like 0, 1, 2, 3, 4, 5, and other things. So that's 13. So we need the previous one, because the previous one instruction is actually some kind of number, the integer 64, used as an argument to that function. Yeah, because we saw that here. Yeah, it's here, the one. Maybe it will be better like this. Yeah, so it's here. This one is here. So we need to take this. We will do it like this. Just instructions, and just give me the index of like 12. So F10, and you will see it will give you the instructions like in the instruction. But again, it's okay, in the instruction, it's an instruction. So once we will be using that, some here we need to take the operand. Yeah, because if you check it, operand. Opcode is LDCIA, but operand is 1. It's the value. It's actually the value. You can see it here. Great. So we have the instruction of the like first or second argument to the main decryption routine. Now, to actually get the first argument to the main decryption routine, we need to process the second decryption routine with arguments to the second decryption routine. So we need to find the decryption routine, the decryption method 2, which is actually on the position like index. You can see here, this index -2. This is 1. This is the 1. Cool. We will do it here. Press F10. And you have it here. If you checked it, decrypt it, method 2. You have it here. IQG, and it's here. Cool. We can continue. Now, what is important? As I told you already, there are 2 ways how these 2 arguments are pushed to the decryption method 2, to this one. Here you can see as an example that these are only instruction load string, and just call the decryption method 2. That's cool, but it's not true always. Here is true. You can see it immediately. Here is true. Nice. But if you go back to the main function, C# code, you can see that here it's not true. Yeah, if you check the IL, you can see that in this case, this is 1. It actually calls the dummy method, which will return the string. So there are 2 cases. Yeah, there are case that there is first case that the second decryption method, like second string decryption method, will be called with pushed argument like as another functions, and the second case that there will be just the pure strings instructions. We need to count with that. So this is exactly what we are doing with the get state string. We will get the state string 1 and state string 2. So get state string will actually do some kind of logic. We will push as an argument an instruction. Yeah, so for example, in this case is an instruction of -4, like the decryption method instruction index -4 and -3. So if we were like in the here, and we will check that again, we can see here that we are still in, this is the offset, -4 mean -3, it's here, -3 here, -4, -3. So we will take both of these instructions, first one, and we will process it, yeah, with the getStateString function. Let's check the getStateString function. You can see we are here. GetStateString, you can see it takes instruction. Let's check it here. Put a breakpoint and continue. And in the instruction, you can see we have the load string LDSTR, and some kind of string, b space b. And you can see it's exactly this one instruction, the first one. Nice. Now we need to actually compare or do some kind of check if the opcode name is call or load instruction, because in this case it's load instruction. But I already told you and showed you that in some cases it's actually a call to dummy method which will produce or return a string. So we can check if it's call, do something. If it's load string, just return operand. Yeah, because you can see it here. In this case, it's in this case, it's actually load string. We saw that. So again, you can see it here because it's an instruction. You can see it here. We have the load string be something. We can see it here. Great. If you wanted to get only the string itself, you can do the operand and you get the string. That's super great. But is there some kind of case? For example, what happened if the instruction is call? Great. Let's wait for this. And we have some call. Yeah. So we are in the routine where there is some kind of call. You can see the instruction now, that the instruction is really a call to some method, which is probably some kind of dummy method returning only the string. And you can actually do that. Yeah, that's super cool, because check that operand, and it's a method. So method body instructions, and you can see that it has only the two instructions. First one is some kind of encrypted string, and the second one is the return. So that's the dummy method, just loading the string and returning. Yeah, great. So once we find this, it's actually some kind of call to some function, dummy function. We will also add it to the methods to be removed to the global variable. Yeah, because later on, after we will process all of this, we don't need the definitions of these methods. So go on, and here we have, this is the magic. Yeah, guys, wait a little bit. This is real magic, because this is a very cool way and very fast way how we can actually call a method. Yeah, because now I know that the dummy method, which is actually the instruction, like when we do is something we want to invoke, because there are two ways how we want to get this string. Yeah, so there is like way that we can do, like if this is it, we can do give me the instruction 0, give me the operand, and I will get the decrypted string, the encrypted strings. Yeah, and I need this, but I decided to do it in a way to be dynamically invoked, and so here it is. Now we can use, you can see that here is the real global variable we can modify. And here is the semi-global variable, the module reflection, which we can't modify, but we can use it, and we can use the value which was assigned to it. So what we do, it's a effectively loaded the module, so we can actually call or invoke a method. Yeah, of this. So what it has is we can check it, module reflection. There is a method which is called resolve method, and you can see it takes a metadata token, yeah, which should be an integer. Be careful, because if you grab the instruction operand, which is actually like method definition of the dnlib type, so if you check here, the metadata token, and the token is not an integer. Yeah, it's type of MD token, dnlib type. So if you want to have this, you can also check that this special type has some method, get member, and you will see that it has method to integer. Great, this is exactly what we need. Yeah, because the resolve method takes integer of the metadata token, and we need to. So this is actually object of dnlib, And this is actually like method of reflection. Yeah, so great. So we will resolve the method. Great, we will get it, the result, and we will immediately invoke it. Yeah, because if you do this, you will get not some kind of method definition like from the dnlib way, but you will get runtime method definition, and you can actually invoke it. Yeah, you can see here is some kind of okay, get me member, and if you check that, it's a module runtime method info. Yeah, and what is pretty cool that this actually has a method called invoke. Yeah, and if you don't know, you can actually do some kind of like invoke, and it will just print you again the possible like overload definition. And we can see that some kind of dummy here is that we can invoke it with some kind of object as a first argument and parameters as a second argument. The parameters are quite nice and self-explanatory, but what is the first argument? Some kind of object. If you don't know, there is a possible way. You can check the find, like it's some kind of method info, runtime method info. So maybe we can try to method info and function invoke, because it's .NET. Yeah, so method info invoke. Okay, and here you can see it. Yeah, so on Microsoft documentation, it's exactly this. And if you check the first argument or parameter, the object on which to invoke the method or constructor. If a method is static, the argument is ignored. So basically, it's a class. Yeah, so whenever you have methods, they are defined in some kind of object. Yeah, you want to invoke it. So it could be class, it could be module, it depends. Yeah, but uh, what you can see here, we in our case, these methods are actually static. Yeah, so we don't need the first one parameter, the object is ignored. Yeah, so it should be null. Yeah, so it's null, and we have no parameters. Yeah, you can see that these are the dummy methods. We have no parameters for them, so the arguments are also null. Nice. So once we do it, okay, return. You can see here that I got the string, some of it. Yeah, great. If I continue, I will do the same. Okay, I didn't want to do this. I will stop it because I want to continue where I was before, even though I was in the on the load string instructions. Let's wait here. 10 or F5, sorry. And now I am exactly where I want to be. So let's jump back. Oh, I don't know. I don't think so we can reach them. So again, if we don't know where we are now, we can do the thing, the method, and MD token or method just itself. Yeah, you can see it here. MD token is this one. So just go back. Just go back and here. MD token and OX. And we are here. Yeah, great. And now we should be processing this thing. So like here. So we should have the first state string should be like B space B, and the second one should be L4. So F10. Oh, sorry, this I won't do it. So you can see it here that it's some kind of space B and L4. Yeah, correct. Here is some kind of dummy check that if if they are empty, we should just continue. Yeah, we will not exit. Yeah, it maybe there is something specially crafted for it. Yeah, to stop our determination of obfuscation, but So just continue. The worst thing would be if we would not find the decryption method, the main. Yeah, but this is just kind of silly check. If there is no things, don't invoke them and continue with the loop of others. Yeah, like continue to process next method or something like that, or instructions. Here we grab the state string 3. What I mean, we now have the state string 1, state string 2. These are actually the parameters or arguments to the decryption string decryption method 2. You can see it here, and you can also see it here. First one, second one, and here is the call to the function. Great. So again, we have here the module reflection resolve method, and get me the decryption method we already took here. Operand MD token to integer 32 and invoke the method. But now, this time, the decryption method 2 is taking actually 2 arguments. Yeah, you could see it here, string and string. Again, if you don't know, you are just basically here, you always can do like decryption method, two parameters. Okay, decryption method 2. Yes, this is the one. And it should have something like we were processing here. Method parameters. I don't know why I decryption method 2 parameters. Okay, something is what? Uh, uh, uh. Yeah, it's instructions. Sorry, I absolutely screw it. You can see it. It's actually I took it as an instruction. Yeah, so it's actually instruction. So if you want to get the method itself, you can see there. Oh my god! Here you can see it. It's actually instruction. If you want to get the method itself, you can check the operand, and it's the method now. Yeah, now it's the method. So you can actually now get the like parameters, and you can see here there are 2 parameters. Yeah, if you want to get like a parameters type, full name, and you have here both types. Yep, pretty cool. Huh. And so we will invoke it with the 2 parameters, yeah, the state string 1, state string 2, and we will get the result. Okay, and the result is some kind of still encrypted string. Yeah, it's state free string, and this result actually goes to the this function you can see here. First one parameter, second parameter, call to decryption method 2, return the decrypted string will be loaded automatically like to on the stack, to the stack, push to the stack, and here is again the second parameter, which is actually the integer 64. So you need to actually invoke, yeah, like this, get this one, and we already took the integer 64 here. So what we will do now, we have, yeah, sorry for that, the string. Here is the state string 3. Here the integer instruction, and but we need to get the value, so operand, and object on what we want to call it or invoke it is null because it's a static method. And you can see that we used resolve method, and we use the instruction because the instruction operand is actually the same instruction operand is actually the same as our decryption method. Yeah, so this is basically the way we did it. And we have the decrypted string which is UK, and yeah, it could be like, hey, is it really decrypted? But yeah, because the Eternity stealer is doing some kind of it's built on like it's builder. Yeah, so you can build your stealer, and there are possible or options like to avoid some kind of locations like countries, and there is actually a language check if there is its location Ukraine, like glory to Ukraine and something like that. So this is the string is actually part of the language check. Great, so we have decrypted string. So this actually works. So what we need to do now, we need to patch this instruction. So I would like to patch this instruction, and this we need to remove. Yeah, but there is a way. There is a thing, yeah, man, that's very suck. And normally we could actually do things like this. Yeah, that we can create, for example, patch instructions like load string and decrypted string. We have the instruction to be patched, like we will be using it as a patch instruction, and we will do something like, for example, insert instructions to some location with the patch instruction. Yeah, and something like, or we can actually grab the location of this. You can see it here. Yeah, this one location, like -4, and we can just assign new instruction. This is normal way, absolutely cool. But there is a thing. If this location of this instruction is a location of some kind of branch, yeah. So for example, if you have like conditions like if else, and this instruction is the first instruction of the branch result, you can do this. Yeah, because these things will patch the instructions correctly, but they will not refresh the branch result, because branch extraction actually has operand, and the operand is a type of like where it will be jumped to. Yeah, so for example, if I remember correctly, this is exactly, there is only one case, I think, for this, but it is enough to actually, like, if we will do that, there is only one thing, and if we will do that, it will result in an exception correctly, and we will not be able to write the module to disk. We can write, yeah, I will show you how we can avoid exception and make it force to write it even if something is probably corrupted. Yeah, but here is actually like here, fx here is function name process command line, and you can see it here that if there is like if else, yeah, and if you check here, oh, here it would be better to see the IL code. You can actually see here that here is our decryption, yeah? The main decryption, here is the integer 64, the decryption method 2, and some kind of dummy methods, and here you can see some kind of branch. Okay, now here. You can see that this one is actually destination of some branch. And that's bad, yeah? Because once we modify this, it will not be populated like it will not be propagated to the branch, and that's bad. Like refreshed. So here is a workaround for this. Yes, here is like workaround, yeah, that we can actually do. Yeah, for example, like this should be absolutely the same, because we actually do like create the instruction and do the assignment, should be absolutely the same as this, but it's not. Because once we will do it like this, we will preserve like the instruction, and like, yeah, with this we can actually force the branch to be like refreshed. Yeah, so we will like it knows the modification. With this not. Yeah, so these are just like things I noted here or commented to be very careful about that, because normally we can use them, but sometimes it will just write you that yeah, on the console that there is probably like some kind of branch or like exception or exception handler or something like that. That basically, if you remove instruction which is part of the branch destination, the first not part but first instruction of the branch destination, it will produce the exception, and correctly, because so this is the way how we can do it. Yeah, so no problem. But also in the end, here is actually like thing I also commented here, yeah, because we don't need it, but sometimes in this case, for example, it's only one thing which is bad, one method. So you can actually would still want to like to save the binary to disk, even if some method would be corrupted. So here you can a way how you can do it. Yeah, you need to just do like module write option logger and create some kind of dumb logger no throw instance, which will actually like mute the exceptions and force it to write to disk. Yeah, pretty cool. So just comment it maybe for your next usage. Okay, so let's continue. We can actually do this. Oh, I should do a few things. I will show you here. F5 once again, and this is pretty cool. Yeah, you can check it. Here we are still like debugging, stopping, debugging, stepping to something, stepping out. Yeah, I'm showing in the intermediate language. Do it in Visual Studio. Do it in C#. Hey man, that sucks. So suck. And that's like literally wasting of your time. Yeah, the scripting language has so many advantages, and yeah, do it. Yeah, I don't know if I'm the only one who is actually doing these things very fast in PowerShell. Yeah, because I don't want to write full featured deobfuscator for something, because I would need to actually maintain it, losing so many time, like too much time, because of what? Yeah, that somebody just grab it from my GitHub without any kind of thank you. Yeah, and maybe it will just create issue. It doesn't work. Yeah, maybe I don't know. Yeah, so this is the cool way how we can actually do it for our purpose to actually do something, some custom samples very fastly, efficiently enough. So we are here. I don't want to be here. I want to be here. And you can actually see here, yeah, again, you can also investigate the types, of course, like here, yeah, but okay. What I wanted to show you is basically that we have some method body instructions, and let's check it first. I don't know what we are on the, like, what is the index we are patching now? 13. So it should be like 11 or 9, yeah, index of 9. This one is the instruction we are now patching. So let's press, you can see it's a LDSTR, the B, that should be 1. 10, F10, and yeah. Now check it again, and you should see the UK. Yeah, here is patched. And if you do this one, it will remove the range, and you can see it's removing the range in index decryption method instruction, which is actually this one -3, which is this. So it's starting to remove from this, and the number of instructions to remove the remove range has 4. 1, 2, 3, 4 instructions. Yeah, because if you don't know, again, you can do like this: remove range, and you can see it takes like 2 arguments. One is index, star index, and second one is count of instructions. So once you do it, you will see that again, instructions UK, and you will see that it's removed completely, and we have only the decrypted string. Like here, UK, and nothing else. Great. But there is a problem, yeah, because you can see, check the offsets. Yeah, there are some kind of offsets, and you can see what offset mean. Offset means like the, for example, offset in method where the instruction starts, and the next offset like of the other instruction is should be actually like for example, offset of this instruction plus like the instruction length should be the index like offset of the next instruction. Yeah, but now you can see that there is some kind of big space. Yeah, this is instruction offset 43 and 72, the next instruction. This is because we removed some kind of range instructions. So why I'm pointing in here is because you can see here that after we process again all of this, like I showed you, what we are doing after processing all instruction in one method, we are actually like doing method body update instruction offsets. There is special function for you. You don't need to recalculate it by your own. You can use this function and it will actually recalculate the offsets. Yeah, so I think it will actually trigger it once again because of the, if we check it correctly, here is the first one. Or C#. No, we are not in process command line. We are now in the OX 06000002. Yeah, we should be here. So you can see that it will be triggered 2 times. Yeah, the decryption. Yeah, this method actually has the decryption implemented 2 times. So I would like to hit it here. And here you can see that now, if you check the instructions, you will see that we have nicely patched the method. Yeah, you can see here you can street the string load string UK and no things related to decryption. And you have see here the second one, glory to Ukraine load string, and it goes to console write line. Nice, no instructions related to decryption routine. But if you check the offsets, you can see that first offset range is here. This is cool. Yeah, you can 28, 33, 38, 43, but now it's the space. Yeah, that's because we removed something. And here is okay. This offset should be okay, but here is again space. Yeah, so we need to recalculate it. So if you do it like this, F10, what you can see here, that it's okay now. Yeah, you can see that it's recalculated. You can see the load string UK and 43, 48. You can see the second one, the glory to Ukraine, and 58, 63, 68. So it's recalculated and everything is correct, which is pretty cool. So this way we actually will be doing the decryption of the strings, removing of the instructions relating to the string decryption and everything. This is the main point. Yeah, I explained everything here. So I think that we are ready to actually stop it. And I will try to not remove, but comment this out. Removing type maybe 2. Yeah. So basically, once we are doing this, we will just process the methods we populated here. Yeah, we populate the methods to which should be removed in this routine, the string decryption, and we also populated here in the like other methods to be removed. Yeah, so we can actually leave this. Yeah, this is some kind of just module writing. I will explain later. So I populate this part because this will be needed just in a second, but we don't need it now. I want to show you the result of what we just did here. Great. It should work. It should work. It should work. So let's debug, and it should be done. It's complete. So let's spawn our new DnSpy, and let's check here the mod. This one is actually the one which should be somehow should have the decrypted strings. And you can see here is decrypted string. It's a mutex name. Yeah, great. You can see also here the glory to Ukraine. You can see it here. And UK string. Yeah, so it's pretty good. It's pretty good now. Yeah, I think it's much better than it was. Yeah, great. But now if you check it here, there are some kind of dummy. Yeah, you can see here all the encrypted methods, encrypted strings are decrypted, but there are some kind of dummy strings, like dummy methods. Yeah, because there is another like thing of string and the obfuscation is that some, you can see it here. Yeah, basically some string are just a part of some kind of proxy method. Yeah, they are just called like in this way. Again, yeah, you can see that yeah, we removed that, but in the GL you can see that there are even though we removed many things and we just did a lot, there is thousand and more. Yeah, there is like really ton of methods which are the dummy ones. Yeah, you can see it here. Browsers, yeah, they are not encrypted. They are not encrypted, but these are dummy, and you will see things in a way like this, and you don't want to do this. Yeah, you don't want to see this. Like, click, what is this? Oh, Kretman, yeah. And what is this? System. Yeah. No, we would like to grab that things, grab that content. If you check the content, it's just method which has load instruction and return, which should be quite easy to find. Yeah, so for example, we could actually like we will try to find them, all of these dummy methods, and grab the string and inline it. And this is exactly what we are doing here. Yeah, here in the comment section. So let's start with this one. Yeah, in this one we are doing again the silly check if the method has some kind of body. If yes, continue. Yeah, if there is no body, like continue with the loop. But if it has body, just process it. So here is again the instruction to array. We already mentioned it, and now we will do some kind of check. If the opcode name is call and operand is method, yeah, because instruction operand, if you check, for example, where we are now, there is some kind of instructional LDCI4, which is basically like loading integer 32-bit. Yeah, so we can check instruction operand and is method. Oh, sorry, is yeah, and I think that it will not because this instruction has no yeah, if the type, the operand type has a argument like has a property is method, it will return true. If there is no some kind of property like is method of the operand, like in this case, it can like return true, which is like the result of this is false. Yeah, so only if there is a call to method. Yeah, if we find an instruction which basically is called to method, we will process it. Great. So let's go to our routine of the identification of the dummy method. So what we identified here, you can see it here, if the method has two instructions. So if the method, like instruction operand, method body, because we already know that it's a call to method. So if the method, the destination, the method itself, instructions count is 2, yeah, so only 2 instructions, where the first is load string and the second one is return. So only these dummy methods. We will just inline them. Yeah, so we have actually what we actually have here. We are not here, we are here. So for example, if we check that, you can see it here, I think. Yeah, if what I'm checking now, if there is a call to some method, you can see it here, to call to method, where the destination method, yeah, you can see instruction operand method body, yeah, so which is actually this one, instruction operand, and we are here, method body. Yeah, so this is our check. Yeah, if it is okay, if it's really like the dummy method, we will just process it. Let's find some method. Sorry, let's find some method which is the dummy one, and here it is. What we get? We will actually get the operand. So we will get the we can see the instruction operand, which is the dummy method. Yeah, is the one which is called. Yeah, not the place where it is called, but it's the place to be called. Yeah, so now we will actually grab the method body instructions and operand. Instruction 0 and instructions on like first instruction is the load string, and where the operand is system, like string. So instruction operand method body instructions operand. Great. And we have the string to inline. You can see it here. Okay, this is just some kind of uh, empty string, yeah. But what we are doing now, we will put this dummy method to the method to the global. This method should be removed later on, not just patched, but also removed of as a type, yeah, as a method. So here is actually we are trying to find the index of instruction. Now we have this string. Okay, we grab that. Yeah, this is actually this one. And what we need to do, we need this index, yeah, of the instruction, because we will be patching it. So we will grab the index here. We have the index, some kind of index. And now we will do this method body instruction index opcode, and we will do the same as we did before. Yeah, as we did here. So I don't care if just this or something like this is destination of some branch. Yeah, because we are doing it in a cool way, in a workaround. Nice. We will do that. And again, after processing all of these dummy methods and inline them, we will be adding them to the methods to be removed. We will, after process the method, we need to update the instructions offset. So, okay, let's say we are done with this. We will do this one. And this one is actually because here, somewhere here, we put the decryption method to probably more times. Yeah, so if you check here methods to be if you would check the methods to be removed, there will be so many like duplicates. I think we can check it here. Maybe, yes. Let's say we want to full name. So much, so many. Yeah, but you can see here the duplicates. Yeah, so this is the reason why we are doing this PowerShell magic, like sort object, property, MD token, and unique. So just give me only the objects where is the unique MD token. Yeah, so only unique methods. So we are not, we will not be performing of removing of method which was already removed. This would actually create some kind of errors, and I don't want to do that. Nice. So here we remove all the dummy methods and all the methods we pushed to the array for methods to be removed, and we will continue here. Nice. And we have here some kind of this thing, yeah, like creating module writer options. Why? Because we removed some instructions from methods. Yeah, we removed some load string and load string. For example, there were like 2 or 3 instructions, like opcodes load string. These things actually modify in some way the stack, and there is some kind of stack memory or stack range, yeah, for the method. Yeah, so basically we would like to preserve the old stack for all methods. Yeah, we don't need to like border. There are more ways. We can actually recalculate the current stack for all methods. Yeah, but this is more like for more working. And we could also set the globally that we would like to keep old max stack, because of the we removed some instructions which were like using the stack, but now there are no instructions like that, so we will do this. Yeah, we will module write option, metadata options flags, and we will like XOR it with or it, yeah, or it with the keep old max stack. Great. And after that we will use the module write option to write it. Very often, sometimes you don't need to do this to actually modify it, like to keep old max stack, so you don't need to use it. You can use it without this. Yeah, only the path. Yeah, module definition right. Yeah, I think it's if you just do this, you will actually get here the way. You can see the overload method for the writing. Yeah, file name and module write options or stream. Great. So we have done with this, and we will be writing the result. Great. So now we should have somewhere C#. You can see how the things looked like before, yeah? Here. That's bad. Yeah, the dummy things. What is the method? The create. So let's spawn another instance of DnSpy and check our modified. Here is the one, yeah, the mod one. And what we can see here, go to here, for example, that's far better, yeah. And if you remember, here was the extremely big class which has the dummy methods and other things. So as I told you, we removed them. These things we removed also, not only patched it. So if you just come back to the main here and check the GL class, you can see that's all. That's all. We have no methods. So all of the methods were some kind of dummy methods. Yeah, if they were used somewhere in the code, they were inlined. Yeah, if they were not used at all, they were just removed. And that's because they are using some kind of obfuscator, so like many strings are not referenced at all. Yeah, there could be probably in some way could be like used in during the runtime, but I didn't find it, so I think that this is just this working. So great. So close it, close everything, and this one too. And I would again want to show you where we are now. Yeah, we are now somewhere what would d4 dot would not be possible to do it, yeah, for you, even if you would use like string token option, string token for manual string deobfuscator. There is a way to use a simple assembly explorer and d4 dot combination in a tricky and cool way, so you could actually get these results, similar like results, but you would have more messy output, and some things would be corrupted. Now we created the custom deobfuscator in some control way, and we can simply modify it. We can do whatever we want. We can also use it as some kind of snippet for other deobfuscators, decryptors. But what you can actually see here, yeah, I wanted to show you this. This is some kind of cool things. Yeah, you see it here nicely, everything. Great, but we can actually see here still some kind of strange things. First of all, yeah, I would, if you check the crate here, I would like to get rid of this SizeOf, you know, because this is some kind of silly obfuscation. Yeah, and after that, we can check it. Go back to main and check it out. Yeah, I would like to firstly get rid of this obfuscation using the SizeOf, because SizeOf float is, I think, 4 bytes, so like to be like 4 and everything. So okay, for this task I would actually I can write the obfuscator for this. It's super simple, but there is already one deobfuscator universal to SizeOf reveal. If you don't know where you can find it, you can like do this .NET deobfuscators and unpackers GitHub. You will find here some pretty cool list, and here is some kind of size of fixer. And this one SizeOf fixer is actually doing this thing. If you check the source code, SizeOf source code, you can see that once it finds an instruction where the operand is timed like the system like SizeOf, here you can see that the instruction opcode is SizeOf. It will just try to like replace the size of boolean with the real value, like for 8 and byte for like 1 with byte and other things. Yeah, so it's pretty simple, but quite efficient enough, so why would I need to do it again? Like grab that, uh we will grab this one and put it here, load it and replace. And we have more than 1000 locations. Okay, super great. Let's check the result. We have it here. Main and better. Yeah, we have no SizeOf. Yeah, at least not here. Great, but what is the silly computation? Again, you can see that it's really silly. Yeah. We could write the obfuscator for it, but again, try to save your time, and for these things we can actually use d4 dot, yeah, because d4 dot could simplify it very efficiently. So let's check the d4 dot, because we already prepared it like for the d4 dot, we already prepared it for the size of replacer and things like this. Yeah, so like d4 dot would not have the great result with this already like clean thing. Yeah, so you can do this, and now it's time for d4 dot, but we can do it all by ourselves. But the subject of this video was about some kind of uh, example how we can write a deobfuscator in PowerShell using dnlib in a fast way, efficiently enough. So let's check this. Let's try to do this. Yeah, it will perform some cleaning, and the most important is check the size differences. Yeah, this one is the clean 140, and this was the with the SizeOf, so it was really reduced. on size, and if you check the results now, and here it is, boom. And that's it, guys. You can see create, and you can see this. That's how it works. If you check, for example, there are some, maybe this could be interesting. There are also some kind of things, maybe another strings. This is not about the analysis of the malware or something like that, but they are really like also IP addresses or URL, the onion string. I think it was okay. You can find it like this. Search eternity, because we are having strings now. So maybe here eternity str eternity, and here. Yeah, great. Here's some initialization. You can see it here. Also the onion side. If you would like to check it, you can copy, go to onion. Yeah, I will run it because it will take some time. Yeah, it was super fast. I will wait for it. And okay, you can basically see everything. Yeah, so it's pretty cool. It's deobfuscated, decrypted what we want to do. And the best thing about this, that we did it in a control way. Let's debug it. We can actually debug it. This is something what I wanted to show you. Yeah. So we are not from Ukraine, so it's okay. It will continue. Here is mutex. We don't care about this. Here something, for example, break on this. Continue. We are here. And if you check, for example, this function add file, we can break here and maybe continue. And we are here. And if you check the locals, we can see it here. So some basic information. Yeah, I should not. You can see it here. Great. We can stop it. So basically it's still runnable, still and nicely deobfuscated. Yeah, and you saw that the most tricky thing was the string encryption. Yeah, it was like split up to two different encryption, like decryption methods, where the one decryption method took another result of two other methods and other things. So it was like quite strange, but yeah, we did it. And if you check the eternity, you can see it here. Yeah, they are like different products. Yeah, stereo minor and other things. Yeah, you can check some things about it and other things. Yeah, but okay, what I wanted to show you is that we created some kind of we can now delete it. I think we can delete, hopefully. But what I wanted to show you that we have also, we created, I firstly thought that basically I created something just for the stealer itself. Yeah, that it should be universal, but there is very high chance and probability that this obfuscation comes like built in with the builder, like with the Eternity builder. So every sample produced by the Eternity builder would be probably obfuscated with this obfuscation. So you can actually use this decryptor, the string decryptor, the obfuscator, to deobfuscate those samples too. You can see here, for example, I have here another sample one. Some extract files, okay. And here is another sample. It's far more large because it has some resources. Oh, infected. Oh, where I was here. Let's grab that sample and put it here. Uh, Let's do it like this to be fast. We will try the deobfuscator on this too. So now if we will just try to check this sample, it's different because I think it's served for like delivering of the worms and other things. And the steers, you can see the similar obfuscation, yeah, the same thing. Here, again, similar, and you can see string, long. Yeah, so the signature should match what we write before. Yeah, and this some kind of dummy things here. Yeah, the thousand of methods and strange. Yeah, okay. So I don't know now what it does, but again we will perform the same routine. So here, right again. Oh, something wrong. I don't know what. Eternity steer should be this. Maybe I didn't stop the debugging. I don't know. Let's try it. It should be okay. Yeah, it's okay. You can see it here. Here is the modified version. What we can do now, we can do the same thing we did before. So again, like the universal deobfuscation size of reveal here, place it here, replace. Okay, here are less locations, but it doesn't matter. D4 dot. And here d4 dot size of reveal is here, and this one, and it's cleaned. Put it here, and voila, bingo. Yep, that's it. That's it. For example, if you check this, nice and easy. Fetch file could be maybe interesting. Fetch URL. Maybe there is some kind of fury here. Yep, great. So you can see that it just works on more uh, Eternity, like more malwares produced by Eternity projects. So there is a high chance that this obfuscation comes with the builder itself, and not like post-processed by some kind of individual which actually buy the some kind of product from the Eternity. So that's pretty cool. We just created some kind of universal string decryptor using dnlib and PowerShell. Again, if you want to just download the dnlib, you can just go to dnlib GitHub. There is some kind of I think link to NuGet. So you can just go to NuGet, download the package, and it will download the package. It will be here, and here is the downloaded package. After that, just open it and get the package, like a library, for example, 4.5.net. Yeah, and this library is the only what you need to actually like for the PowerShell. Yeah, where it is. Here is one. Yeah, we are using just the dnlib and the PowerShell script itself, what we created. Uh, yeah, that's pretty cool. Little note: if you are still here, still watching, there is like a last quite interesting trick I want to show you, but it was a part of the original one sample. I want back this one, actually Eternity Deobfuscator, restore here. Yeah, so if you check in DnSpy, be careful because DnSpy is super great tool. Yeah, I understand and I absolutely agree with this statement. Yeah, but what is true that the decompiler is not up to date with the ILSpy engine. Yeah, so if you have basically DnSpy is using the ILSpy engine. You can use the ILSpy on your own. Okay, I don't have it here. It doesn't matter. I have it here. Not the latest one, but almost latest, the ILSpy. So what I want to show you is that there are methods. Yeah, there are also methods which are like this. For example, this second one. And what you can see here, this looks strange and you can't click it. Yeah, so if you just check it in ILSpy, so first of all, if you want to see these methods and you can see it very often, it's caused because you have hidden the decompiler produced methods and types and other things. Show hidden compiler generated types and methods. If you do it in DnSpy, you will see that. Yeah, it's super strange, but you can see that and you can see some things. Yeah, so pretty cool. But what is cool in the ILSpy that it has the latest engine because it's the ILSpy. But if you check the main, maybe we can switch to this. And if you just jump back to some of the routines like the create, and here it was, I think, this one, you can see the code. Yeah, that's much better. Yeah, because you saw it here. It's like, yeah, generate password, generate network. Yeah, but it's here. Yep, super cool. So there are some things which are better to check also in ILSpy itself. Yeah, not only in DnSpy. DnSpy, the compiler is based on ILSpy, it's using that, but it's not able to use the latest engine now. Yeah, you know, it's super hard to actually try to use the up-to-date things. Yeah, there are so many dependencies. This project of DnSpy is extremely huge, so it's even impossible to do it. And heads off to the developer of DnSpy, but you can I would quite recommend to also use the ILSpy, because in ILSpy you have also some kind of IL switches. Yeah, so you can see also the IL code and you can see also IL with C sharp. Yeah, I found it buggy in this version, but the latest version is working. The latest version is working, and the IL code with C sharp is actually really cool. Yeah, the combination of IL and C sharp together. But yeah, pretty cool still. And that was like almost the last tip uh, to the end of the video. I hope you enjoyed it. I hope I covered like many things. Mostly I wanted to cover like things like this, how it is cool to use PowerShell for some fast decryption or deobfuscation of .NET. Yeah, or quick, or do it for some custom things. Yeah, so much more like much faster than C sharp. But there are cases, yeah, when you want to build something, what you want to manage, yeah, in some kind of project, build an executable, do some great GUI for it, graphic user interface for it. The C sharp is much better. And very often you can just copy paste the C sharp decompile results from the DnSpy or ILSpy just to your Visual Studio and use it right there. So the C sharp is pretty good too. Yeah, but there is some kind of advantages to use the PowerShell for some quick task. And yeah, this was just a little show off or showcase how you can do it or how you can use it. Uh, Also, it's much easier or maybe better like investigate the possibilities of dnlib and other things to play that with that like from the PowerShell itself. I hope you enjoyed it, and see you next time.